Sweet. Okay. It's funny, you know, doing these online doesn't make me less nervous than doing them in person. Counterintuitive finding for tech conference. So, I'm not a networking professional, but I really wanted to do some research on the protocol suite, because I was curious how the miracle of sending and receiving virus-free content on the internet worked. So I would love any feedback you have on protocols I didn't consider, or like weird edge cases, or your personal experience in the browser wars, if you were like in the scene then, really anything. So yeah, if you have any feedback by the end, I would love to know what you think. So yeah, this presentation, as I said, begins just with the question of how do servers do the dangerous work of sending data to each other on the wild, wild web? Most of the web is based on HTTP request response model of client-initiated transactions. So your browser, the client politely requests data from a server, and then the server responds to those requests. And even better, with TCP, which HTTP is based, the client will send an acknowledgement that the data is received, so the server can resend if the data gets lost and guarantee that the data sending is going to be reliable. Also, that allows it to do some ordering and sequencing. So your data with HTTP will arrive slowly, maybe, but the order is guaranteed and it will definitely arrive. So TCP is described as a connection-based because of that request-response connection, and a stream-oriented protocol. So I knew this, I guess, but this is all I knew, and I was pretty excited to consider an alternate protocol, UDP. UDP doesn't work in the browser, but I thought it was a good example to just talk about a different way of doing this. So the user datagram protocol is an alternative to TCP, and while communication is still initiated by the client, the protocol is connectionless or message-oriented. So the server will send data without checking on the state or readiness of the client. It's not reliable. It doesn't provide guaranteed delivery. It doesn't guarantee order either. I was reading about this, and people on message boards were pretty mean about it. My favorite dad joke that I found about UDP was, I could tell you a joke about UDP, but you might not get it. Ha ha ha. Because it's not reliable. Anyway, people got really worked up about this, and from which I can only conclude, it kind of felt like the relational database NoSQL arguments, where the idea of a non-reliable data sending was just like too much for people to handle, which I can identify with. UDP is used, I can't say for sure that Spotify uses it or Zoom uses it, but I think they probably use something like that, like it, where sure, like sometimes your video connection might seem a bit fuzzy or off, but it does allow data transfer at a fast enough rate to provide like a close to real-time video call, or it also is used in gaming. So I'm told. I don't know. I don't play games. So with that comparison in mind, and this is just a brief visualization of the two. So you see the sender sends you, the client will send something to the server, and then the server acknowledges that you requested a data transfer, and then you acknowledge that you've received the data back from the server. Whereas UDP, the client, I guess, initiates a response or request, and then the server just sends a response. Sorry, I was seeing the server and the client as a laptop, but I got the two confused. Yeah, so this is the data. This is, I guess, your laptop requesting data, and then this would be the server, whatever, sending you information. So yeah, you would first request for UDP. So enter the problem. I guess this is the problem in the early mid 2000s, where an HTTP is described as too chatty. So basically, this just means it requires a lot of reassuring back and forth between client and server. And in this period of time, we were seeing the rise of more real-time web applications. So people wanting to do video calls, wanting just like faster communications, wanting to do sort of like chat back and forth communication, where you would send and receive data super quickly. This is also the time of the great browser wars, which I was very interested in, which kind of factored in to this real-time problem because the browser is based on TCP. So a lot of what you could do was just limited by what the browser had. And my impression is like Netscape and Explorer had a bunch of different things. So trying to build an application that accommodated all the different browser features, and it was a lot more difficult during this time. A solution that they had at first was long polling. So you would send a request to the server and they would open a persistent connection. And then you could kind of send request response back and the server could push notifications back to you. Yeah, this is a XML HTTP request. And this is not ideal because while it eliminates the constant client needing to initiate requests to the server, the cookies and header data in the HTTP request model is super bandwidth intensive. If you remember back to UDP, the datagram is like a few orders of magnitude, I think, smaller than an HTTP request. So this still wasn't a perfect solution. And also, you couldn't really guarantee message order in this phase. So while the connection was persistent, like a big bonus of TCP you couldn't take advantage of because sometimes your request response would be scrambled. So imagine bidirectional connection based on protocol with the reliability of TCP, but that was low latency and message oriented like UDP, and also built to work in the browser. So from this, enter Websockets. So by the mid-2000s, frustration led developers Michael Carter and Ian Hickson to introduce a new standard for modern real-time bidirectional communication on the web that they coined WebSocket. And Google Chrome actually fully supported WebSockets by 2010, which was kind of surprising because their initial spec was very unreliable, so it took a while to nail things down. By now, all browsers support WebSockets. Something kind of cool is you can still find the IRC chat and the W3C mailing list where they started planning out WebSockets. And this is sort of a tangent, but the coolest part of the chat is they talk about whether or not wanting your IRC chat log was a valid privacy concern. And like a lot of people were like, to expect that kind of privacy is antisocial and it's not Web 2.0, which I thought was like super prescient and really interesting that in 2010 they were kind of like already feeling pressure to log everything and have, kind of grapple with the privacy concerns that we have today. So WebSockets, yes, I've described them. How do they work? So to establish a WebSocket connection, the client uses the standard HTTP protocol to request an upgrade from HTTP to a WebSocket connection. So if a server supports WebSockets, it will respond with HTTP 101 message to switch protocols, and then it will replace the initial HTTP connection with the WebSocket connection that reuses the underlying TCP connection. So this diagram is super simple. It looks kind of like long polling, but is not. WebSockets are more message-based, and the messages that they send have fewer cookies and header data, so they're a lot lower bandwidth and a lot faster to send. And the good news with WebSockets too is that if your server doesn't support them, you can just keep doing stuff with HTTP. So pros, yeah, they don't require the client to pull the server for new messages. Instead, the server can initiate sending messages to the client whenever the data becomes available. And they use a frame-based messaging system that I said that reduces the amount of non-payload data transferred. And they also have a mechanism to detect dropped or disconnected clients and can handle supposedly up to 1,024 connections per browser. Seems intense. We use WebSockets at LifeLink for our chat application. It's really good to use for chat applications because, as you can imagine, our servers are pushing messages to the client that you have open in the browser. Maybe we wouldn't use them if we were using like an iOS app instead of a browser app. Who knows? But they're great. They work super well for us. A downside that I found is that they don't automatically recover when connections are terminated, but there are a lot of WebSocket clients that can address this. Client-side libraries that can address this. We use Socket.io, which is a JavaScript library. There are tons of different ones. Another downside is, like I kind of mentioned, they had a contentious beginning with an unstable spec. Let's see if I can break out of this presentation. I just want to show you the diagram. Can you guys see this for the crazy cache poisoning security risk? I'm not going to go into it, but this is a really interesting, I thought, case study of really pushing hard to release this really cool, useful protocol and having a couple issues that initially turned people off to using them. So my final comparison, and this is a bit stretched, but I'm going to say it because it's funny to me, is that WebSockets might remind one of Princess Maria, I'm not going to pronounce her last name, but a Byzantine princess who scandalized Venice by having guests at her wedding using the fork instead of their hands. And some old hermit, St. Peter Damian, was really upset by this and said that she died from the plague unusually soon because God punished her for the vanity of using forks. Crazy side note. But okay, so maybe at first WebSockets were a bit difficult to adopt and odd, but they're so useful and in such common use now that they're like the fork. We can't imagine living without them.